This is section 2.3, the precise definition of a limit. So, a couple of things to note here. This thing that looks like an E is called epsilon. This is the Greek letter delta. So when you see these in your formulas, epsilon and delta. So this definition of the limit, precise definition, says let f of x be defined on an open interval about x sub 0, except possibly at x sub 0 itself. We say the limit of f of x as x approaches x sub 0 is the number L. And so that's that limit. Limit as x approaches a number of f of x is equal to L. If for every number epsilon greater than 0, there exists a corresponding number delta greater than 0, such that for all x's, the absolute value of x minus the x sub 0 falls between 0 and delta, and the absolute value of f of x minus the limit is less than epsilon. Now that's a lot of stuff. But if I put this paragraph here, one way to think about the definition is to suppose you're machining a generator shaft to a close tolerance. You're going to try for a diameter L, but since nothing's perfect, you have to be satisfied with a diameter f of x somewhere between L minus E, or epsilon, and L plus epsilon. The delta is the measure of how accurate our control setting for x must be to guarantee this degree of accuracy in the diameter. And so the tolerance for error becomes stricter. As that happens, we have to adjust delta. That is, the value of delta, how tight our control setting must be, depends on the value of epsilon, the error tolerance. All we're going to do in this section for now, we're not doing proofs of this, we are algebraically finding a delta if you're given an f and a limit, an x sub 0, and an epsilon. And so there's two steps. And I think you'll see it when we start working the problems. But solve the inequality, this inequality, to find an open interval on which the inequality holds for all x not equal to x sub 0. And then find a value of delta greater than 0 that places the open interval centered at x sub 0 inside the interval a to b that you were looking for. And so don't worry about that. Let's go look at the problems and see how we do. There are only 4 problems, and so just be ready, have your calculator, because you will need to do some calculations. The number 1, for the given function f of x and values of L, x sub 0, and epsilon greater than 0, find the largest open interval on which the inequality is going to hold. And then determine the largest value for delta greater than 0 such that this holds true. All right? So here's what we're given. We're given that f of x is 5x plus 6, L is 41, x sub 0 is 7, and epsilon is 0.2. So you're going to solve this inequality here. So we're just going to plug in the pieces we're given. So the absolute value of 5x plus 6 minus 41, I'm just plugging in these pieces, is less than the epsilon of 0.2. So if you have an absolute value inequality, remember that the inequality has to be greater than the negative value and less than the positive value. So I've said that here. I put the negative 0.2 on the left, positive 0.2 here. I no longer have the absolute value bars, I just have what was in here. And so that's right there. I can combine the 6 and the minus 41. So now I have negative 0.2 less than 5x minus 35 less than 0.2. To solve that, we have to get rid of the 35 first. We do that everywhere. On this side we have 34.8, on this side we have 35.2, and we have 5x in the middle. We're solving for x, so we're going to divide by 5 all 3 places. So we do that. Now I have x falls between 6.96 and 7.04. That is the interval that is asked for in this first part. So 6.96 to 7.04. And we're going to find the largest value of delta that makes this work. And since x sub 0 is 7, we're going to go with the 7.04. That will be our delta. So that's number 1. Let's look at number 2. For the given function f of x and the values of L, x sub 0, and epsilon, we're doing the exact same thing. So we're given an f of x that is square root of 14x plus 51. L is 11, x sub 0 is 5, and epsilon is 0.01. So we will solve this same inequality here. We'll put in our f of x minus our limit less than epsilon. And so then we have to have the negative of that here, the positive here. The inside, we do not have the absolute value anymore because that's what we've done here. Then we can add 11 to all three things. That gets rid of the 11, and we have this statement. Then we have to square all the parts to get this out of the radical. So we square this, this, and this, and we're left with this statement. Then we have to subtract the 51 from all three sides. That leaves me this statement. We have to divide by 14 all three places, and then we get this, which is our interval, 4.9843, 5.0157. Since we're centered on x sub 0 is 5, the 0.0157 is our delta. Okay, let's go look at number 3. So we are doing the same thing. Here's our equation, our inequality that we're solving. Our f of x is x squared minus our limit, which was 25, less than epsilon 0.15. We have the negative 0.15 less than what's inside the absolute value, less than the positive. We are going to add 25 to all three to get rid of it in the middle. We're going to then take the square root of all three. So now we have this. This is our interval. But since x sub 0 is negative 5, we're going to multiply the inequality by negative 1 because we need to have that. When we do, we have this, and what we have to notice is that our symbol changes. If you multiply or divide by a negative with inequality, your symbol will change. So now here's our interval, and since we're going to put them in order, it's negative 5.0150 to negative 4.9850. And since we're centered on the negative 5, 0.0150 is your delta. So a couple of things to watch there for that one. Let's look at number 4, which is our last one. Number 4 is a little bit different. They give you f of x, x sub 0, and epsilon. They did not give us L. And so if we're still trying to solve this, since this is a linear function, L is the value of f of x at x sub 0 for this question. Because it's linear, we can just direct substitute that. So L is going to be 7 minus 5 times 2. X sub 0 was 2. That gives us negative 3. So our L is negative 3. So now we have this as our statement. Absolute value of that minus a negative 3 less than 0.01. We do the negative here, positive here. And then we have, this is 10 minus 5x plus 3, like 7 minus 5x plus 3. So that becomes 10. So we have the 10 minus 5x. Then we are going to subtract the 10 from all three, and we're given this statement. We'll divide by negative 5 on all, and if we're dividing by negative 5, those symbols are going to flip. So now we have 2.002 greater than x greater than 1.998. When we write the interval, we will write it like this, least to greatest. And since we are centered around x sub 0 is 2, then delta will be 0.002. So I think that will get you going on those 4 questions, and that will be how to algebraically find your delta.